All right, guys. So today we're going to talk about sum and difference identities. That's where they are on the sheet. Everybody good? And this is the worksheet we're on. And I just created this worksheet as just an easy way to find them, look for them, make sure we understand what they're saying. Okay, so there we go. Got a pen. So it says simplify using sum and difference formulas, then find the exact value using the unit circle. 1 through 5 are in degrees and 6 through 10 are in radians. So even though this doesn't say degrees, which it should, we're going to go with its degrees. Which one on the sheet has sine times cosine plus cosine times sine? In that section on your reference sheet, let's see, what did we just say? Sine times cosine plus cosine times sine, is that this one? Okay. So, whoops, wrong way. So this is a sine of A plus B because that's the formula that's given. But what are A and B? It said sine of A cosine of B plus cosine of A sine of B. Is that what the reference said here? Okay. So therefore, A is what? 118. And B is 62. Anybody know what that adds up to? I think it's 180, isn't it? Okay, can you go to your unit circle? The ordered pair at 180 in degrees. We are so used to radians now, we forgot degrees, but the ordered pair at 180 is negative 10, is that correct? So what's the sign? Cosine sine, the sign is just 0. So what I would like to see, if you want to do the rest in your head, that's up to you. But will you make sure you write those two things down, what it simplified to, and then what you traded it for? Does that make sense? Okay, it'll make more sense in a minute. Yeah, it makes great sense. How far? We've done one example. We have no idea what you're talking about. Sorry. This one says cosine A cosine B plus sine A sine B. Maybe, is there one that looks like that? Cosine, cosine plus sine, sine. Does that look like this one down here? Cosine of A minus B. Everybody see what I'm pointing at here? So this would simplify to cosine of 47 minus 17, which would be the cosine of 30. What's the ordered pair at 30, guys? Square root of 3 over 2, 1/2. So which of those is the cosine? Square root of 3 over 2. Does this seem okay so far? Pretty easy? All right. Oh, these are tangents, but I don't think they're super tricky. Tan plus tan divided by 1 minus tan times tan. Which one is that? Tan plus tan, 1 minus tan. Is that tan of A plus B? Right? If it has a plus on the top and a minus on the bottom. So this is the tangent of A plus B, which comes to be the tangent of 180. Okay, again, the ordered pair at 180 was negative 10. So what is the tangent there when you put y over x? 0? Can you guys try number 4 on your own? This one has a minus on top and a plus on the bottom. So that one is tan of A minus B. should hear flipping of sheets here unless you have this all memorized, but the tangent at 150, that was the ordered pair, so the tangent y over x. Anybody getting negative square root of 3 over 3? Okay, so these are the two things I'm looking for, how you simplified it and then what the value turned out to be. All right. I'll leave 5 for you to come back to. I don't think it's anything tricky. Let's do 6. We're in radians now, right, guys? But same thing. Cosine, cosine minus sine, sine. Emma, can you find that on the sheet? Cosine, cosine minus sine, sine. Cosine A plus B. Did everybody find it? Adriella, you spotting it? Okay, I just... that would then, A and B are going to be these two numbers. Make sure that they're, both A's are pi over 9, both B's, we're good. Okay, so that becomes the cosine of pi over 9 plus 8 pi over 9. Now, if it's some funky fractions, do you remember how to add them? You just leave the pi out and use your calculator. But this one you should be able to do, right? 1/9 plus 8/9 is 9/9 or 1 pi. So the cosine at pi, the ordered pair was -1, 0. So the cosine is -1. Which one do you want me to do, 7 or 8? Or do you want to do for me? What? 8? Okay. 8 has a plus on the top and a minus on the bottom. Plus on the top, minus on the bottom, and it's got tangents everywhere. A, B, A, B. That seems like tan of A plus B, yes? And what are the A and the B? 5 pi over 9 and 5 pi over 18. Now, some of you are good with getting that to be a common denominator, but you can use your calculator. It's okay to just type 5/9 plus 5/18. It should be 10/18 plus 5/18 is 15/18, which will reduce by 5 to... will reduce by 3 to 5/6, yes? And if you typed it, you got 5/6 much faster than I did getting a common denominator, because your calculator reduced it. Need me to show you on the calculator, or you got it? What was it, 5/9 and 5/18? Don't forget the pi in there, by the way, when you're done, but we just left it out for the calculator. So it was 5/9 plus 5/18. Math, enter, enter. Gave me 5/6. Okay. And it was a 5 pi over 6. And I still am supposed to find the tangent. So the ordered pair at 5 pi over 6 is negative square root of 3 over 2, comma 1/2. So the tangent is, anybody? All right. At the bottom of this sheet, well, these are just more of the same, right? Oh, okay, let's go to the bottom. Your homework is just gonna be go back and finish these. So let's talk about this one. Oh, this is weird. There's a negative. Let's do 12 first. We'll go back to 11. Number 12, we need one that says sine, cosine, cosine, sine, and a minus in the middle. Sine, cosine minus cosine sine. Anybody find it? Which one is it? Sine A minus B. What is our A here? 5 thetas? Is everybody okay? And our B is 3 thetas. So we can't solve this, but we can simplify it. What are we going to get? Sine of 2 theta. And you can put the parentheses or not put the parentheses, doesn't matter. Okay, let's go back and look at 11. 11 is concerning me because it appears to me that this is a negative 4 theta, right? Okay, there's a minus in between the functions up top and a plus on the bottom. Which one is that? Tangent of A minus B. Okay, but our A is negative, I think, right? All right, so A is negative 4 theta minus B is 3 theta. So we get this to simplify down to what? Negative 7 theta. Everybody okay? Now, I would like us to look at some that we skipped. Can you jump back up to the even and odd identities, which are above this? What does it say when there's a negative, when the even and odd identities, just look at that section for a second. Do I have it on a slide? I'm afraid I don't. But I don't. The even and odd identities either say if a function is even, you can throw the negative away. If it's odd, you can move the function out front, the negative out front. So look at those. Do you see, like, cosine is an even function. If you have a negative inside the parentheses, it goes in the garbage. Are you looking at with me here on this even odd section right here? So what happens when tangent has a negative inside the parenthesis? It goes out in front, right? Do you see what I'm talking about right here? On the sheet, it says tan of negative theta equals negative tan of theta. So this would also be equivalent to negative tangent of 7 theta. I just want to introduce you to those even and odd ones. We don't do them very often. Yes. If this was I don't think I'm going to ask it on a quiz question, but no, I would accept either one. Okay. Number 13. This one's got a negative again too. It's cosine times cosine. So cosine A, cosine B, plus sine A, sine B. Which one is that? Cosine of A minus B, but what is our A? V, right? Yeah, a positive V is our A. And then it's supposed to be minus, and our B is a negative V. I don't like this question. So what does that become? Yeah, cosine of 2V. Now, look below the section we're talking about today. Do you see some cosine of 2 theta trades down there? So eventually we're going to look at those as well. There's 3 different things you could trade a cosine of 2 theta for. But that's not today's lesson. All right, I'm going to skip, let you try some of these. I'm going to skip all the way to the next page, maybe? Is this at the top? Okay. This is on your notes sheet, yes? And this is off the reference sheet. They're the same things. Is everybody okay that here they're just using the Greek letters, alpha and beta, instead of A and B? Okay. All right. The whole point. Here's an example of why these are used. But I will tell you they're disgusting, so we're not really going to do these. Okay. Cosine of 375. Not on my unit circle, right? What are two numbers on the unit circle that could add up to 375? Anybody know? Like 300, okay, is 15 on my unit? 360 and 15 was suggested. 15's not on my unit circle, right? What else? 375. 75's not on my unit circle, but let's... 315 and 60, are those both on there? Is that what it says on your paper? I didn't look, because we can do this multiple ways. 330 and 45, okay. Well, let's try this way then. See if we get the same answer. All right. So we are going to expand this using the reference sheet definition, okay? This time we're going the opposite direction. Instead of condensing, we're expanding it out. So it's going to be cosine of what? Using the numbers Ben gave us, we're using A as what? 315. And times cosine of B, which is 60. Minus sine of 315. I don't know if I can move this all over. Of course not. Okay, let me think I can select all this and then say move over. What did I need at the end? Times sine of 60, is that right? You did this in trig, I'm sure. Okay, cosine of 315. Now flip your sheet over. The cosine at 315. 315 is got an ordered pair of square root of 2 over 2 and negative square root of 2 over 2. You don't have to write that down. I'm just trying to help us here. So the cosine is square root of 2 over 2. And then 60 has an ordered pair of 1/2 and square root of 3 over 2. So we would put the cosine of 1/2 in here. Minus, what's the sine? Help me out here, guys. The sine at 315. Negative root 2 over 2 times the sine at 60, which is square root of 3 over 2. Okay. If we multiply these two together, we get square root of 2 up top. Whoops, I don't know. That's a really funky looking square root. Sorry. Square root of 2 over what? When you multiply fractions, what do you do with the denominator? Actually multiply it, right? It's only adding and subtracting. You keep the denominator. Okay, multiply these together. They are both in radicals, so we can multiply them together. We will get a square root of 6, and the denominators multiply to make 4. But what happens here? Minus a negative becomes plus. And then we can combine those all over one common denominator if we wanted to. We just found the exact answer for the cosine of 375. I suppose if you didn't have calculators, you would need to know how to do that, right? Like if we didn't have the ability to just type in the calculator cosine of 375, or if there was a reason you needed an exact answer. I just don't find this very fun and useful because we do have calculators, right? Is this what they got, by the way, when they did it with different numbers? Okay. There we go. There was theirs finished. So that was a nice little commercial break, but I'm not going to make you do one of those on a quiz. Is that okay? All right. Do you need me to do any more examples of this? Because this is the same stuff. It says condense into a single logarithm So show me that. Like, just talk me through 7. Tan plus tan over 1 minus tan tan. Tan plus tan over 1 minus tan tan is the tan of A plus B, which are 48 and 102 for this question. So that becomes the tangent of 150. And it says then find the exact value. So please make sure you show me that you simplified it. And the tangent at 150 is 1 over negative square root of 3 or negative square root of 3 over 3. And you can just go directly to that. I don't care. So seem okay? That goes through some are, oh, these say simplify, don't evaluate. Okay, which one you want me to talk about here? Anybody pick one. Which one? Did you say 13? 14, okay, 14, sorry. Tan minus tan over 1 plus tan tan is tan of A minus B, right? But what are the A and the B in this question? Y and pi over 8. So this is your answer, guys. I like these even better. There's nothing you have to look at your unit circle for. Does that make sense? It's just an expression. Yep, just write it down. So like even number 11, which has all numbers, even number 11, which, let's see, cosine minus sine would be what? 73 plus 21, which would be the cosine of 94. Did I add that right? So this is all I want to see. Don't type it in your calculator or anything, but a lot of them are going to have a variable in it, so you're not going to be able to type it in the calculator anyway. Okay? Is that it? Yep. Okay. Your practice is to finish those worksheets. If you will notice at the top of 10B, if you look at 10B, am I right? The very top is some more of this stuff. 10B. Yes? Everybody get to 10B? It's like 4 pages later because of our crazy. It's some more of this same stuff. So you could get that done with too, because worksheet 10 is going to be homework on like Monday. So if you want to get the top part done, go for it, okay? Finishing 8B, 9A, and the top of 10B if you want. If you want to save 10B for later so that you have a chance to review these concepts, you can, but I don't think it's super tricky if you want to just get them knocked out. I was going to do some other kinds of stuff that you do with this, but I'll save it for next week. We should have an easy day, don't you think? Is there anybody who is planning, who's not a junior, who needs to do a retake on something on Tuesday? Remember, Tuesday all the juniors are going to be gone testing,